Hello dear students. In this video, we will extend our knowledge about malloc function and we will understand how to create array using malloc function. So as you see in this particular slide, I have written some declarations and I have explained how malloc can be used, malloc library function can be used for creating an array in this program. But before we see this program at full length, let us work on an empty slate and try to understand that what we are talking about first. Let's say in my program I declare one pointer, int pointer p. Now you know that the pointer p will be stored in the memory and this pointer p is capable of storing address of an integer. Just don't bring arrays into picture. But you know that p is a pointer and it can point to any integer. Now have a look at the call to malloc, which we were seeing in the previous video. Now, first of all, you can start reading from malloc. Malloc means memory allocate, and how much memory we want to allocate is written in the bracket after malloc. Correct? Now, how much memory we want to allocate? We have written size of int multiplied by 5. Now, just imagine every integer on my computer consumes 2 bytes. Size of int on my machine is 2 bytes. Then 2 multiplied by 5, that means total of 10 bytes will be allocated by malloc. We can say continuous sequence of 10 bytes will be allocated by malloc. So I have shown that the allotment is done, let's say from location 100, that is address 100 to 109, that is 10 bytes. Okay. And the first address, the begin address, will be loaded in the left hand side pointer p. So this complete sentence can be read as p stores the address of newly allocated bytes. Of course, p stores address of the begin address or begin address of the newly allocated bytes. So I have shown p is storing 100. But now just imagine this picture where 10 bytes are allocated. Now 100 and 101, the first 2 bytes can store first integer, correct? 102 and 103, the next 2 bytes can store second integer. 104, 105 can store third integer. 106, 107 can store fourth integer, and 108, 109, 2 bytes can store the last integer. So actually by writing this line, I agree that I have allocated 10 bytes, but those 10 bytes, you know, is actually a home for 5 integers, and that too 5 integers can be stored sequentially. So you tell me, isn't this an array? Yes, it is an array of 5 integers. But just check one very important thing over here is there is no name to this array. Usually, not usually, always we declare an array like this, int a square bracket 5. Then a is the name of the array. But you know that even if you declare a like this, an array, that a is a pointer to the array. It stores the base address. Correct? So we still have a pointer to this array. Note, p is a pointer to this array. And p stores the base address of the array. Correct? Now have a look at this statement. Okay, I agree that we have directly seen the code for allocating an array, but I hope you have understood this. What if you needed a float array? Suppose you need a float array. What will you do? What you do is you declare a float pointer. Let's say float pointer w. Now you know that w can point to any float. Now what we can do is we can say w, you point to newly allocated memory, malloc, but say we want an array of 4 floats. 4 floats we want to store. So what we will do is we'll say size of one float, okay, multiplied by 4, because that many repetitions of those floats we want. And you know, this is a painful stuff here. You will have to write the typecast saying that the left hand side pointer is a float pointer and this pointer should point to newly allocated space. So how much memory will be allocated by malloc? Is size of float into 4. Just imagine on my machine, every float consumes 4 bytes. And then into 4 we have done. So continuous sequence of 16 bytes will be allocated. Let's say that the first byte is 200. Then the last byte should be 215. That will make 16 bytes. And you all will agree that the first 4 bytes, that is 200 to 203, can store first float, but 204 to 207, am I correct? 4, 5, 6, yes. To 207 can store the second float. 208, correct? To 2011 can store third float, and 212 to 215, the last 4 bytes, can store the fourth float. And this W is going to store the address 200, and it's going to gracefully point to the first float. Note, W is an ordinary float pointer. It's a float pointer. So it is pointing to the very first float. But importantly, it knows the base address of the array. Please try to understand this. So this is as good as, this is as, or why as good as, this is array of 4 floats. Array of 4 floats. So what you might have done is that you might have declared float, let's say b square bracket 4. Even this will declare an array, isn't it? But what it will do is it will give name to the array. B is the name. But here, watch it. We have not declared an array. We have declared a pointer to start with, very small pointer. And then we have requested memory. Malloc is basically requesting memory, that please give us this much memory so that we can store 4 floats. And that too 4 floats sequentially, one after the other. And the big point you notice is there is no name to this array. Come on, but name itself here is W. W stores the base address. So coming to our previous slide, what if I tell you that you store some value like 30 here at this location? You store 30, let's say. Then you just say P square bracket 2 equal to 30. Oh, but this is like our array notation, usual array notation. You would say, no sir, how can you write this? P is not an array, P is a pointer. Just check the declaration, I am underlining that again. You would say P is a pointer, how are you writing it as an array? Come on, even if I would have declared P as an array like this, still it would mean the same, because the name of the array itself is the base address of the array. Tell me, how will this get magnified? How will this get substituted by C compiler? It will be asterisk P plus 2 equal to 30. That means value at this address, which is this address 104, P plus 2, you know P is 100, and you are jumping by 2 locations. 2 integers you are jumping. So this is 104, and we are saying value at 104, asterisk we have given before should be 30. But nice part over here, you know, is that you can treat the pointer as if now it is an array, and it has to be an array. Come on. So what will happen? What will happen if you write, let's say pi equal to, let's say 50, and I is 4. So this is clearly P4 equal to 50. This location, fourth location of the array, is going to store 50. But what does that mean? Pi actually mean go to the address P plus I, and then the value at that address should be 50. This is what is the meaning of the statement actually, isn't it? Or this is how it is interpreted by C language. So let's attempt writing a code here. Let's say that the question asked is, let me change the color of the pen. Let's say the question asked here is, write a program to store n integers in array. Okay, and print the values in the array, values stored in the array. Simple. So we just want to input the array and output the array. Okay. But notice we want to store n integers in the array. So what we do in our program is we declare n. Now n will tell us how many integers you want to store, and we will declare a pointer. Both could have been declared on the same line anyway. Okay. Now first thing we will ask the operator is to enter n, enter the value of n, and let's scan the value of n. %d and n. Let's say user enters n from the keyboard as 5. So what user wants to say is that user has got 5 values to store in the array. So don't you feel we should create an array exactly of size n, not one more, not one less? And how can you create the array of size n? Just say p is equal to, p is an int pointer, so typecasting is needed. Further malloc, then size of int multiplied by n. Just check if n is 5 here, as in our example, if n is 5, this will exactly create array of 5 integers, and p will store the base address. P is going to store base address of that array, isn't it? Now you want to input these values. So what you can do is you can say enter values in the array, one by one values. Okay, \n, let's say. And then we will write a for loop where I goes from 0 to n minus 1, I plus plus. So this loop will clearly go from 0 to 4 because n is 5. Let's declare I also on top. There is one more variable I. Okay, n and I, both variables. And here we will write a scanf, and scanf will be %d. We are reading integers, but then what we can write is and pi. And pi. P is pointing to the base address of the array that we have allocated, correct? And when I is 0, we are reading P0. When I is 1, we are reading P1, and so on. So this is the way how you can store the values in the array which is dynamically located. And how do you print it? Simple. You just write a for loop in which you write printf pi, of course with %d pi. But our topic or our topic of interest is how do you create an array dynamically. See that you are not declared this array, but you created it dynamically using malloc. That was the topic. Let's come back to our slides. And here full length program has been given about how do you create array of size n. You can see that the pointer is declared. Then we ask the size of the array, n is entered, and then we allocate exactly the space required. Size of one integer multiplied by n because we want to store n integers, and p stores the base address. After that we keep asking the values. Now you notice here we have written p plus I in the scanf. We could have written, instead of p plus I, we could have written and pi. But you know that this notation is same as p plus I. Don't say that you don't know this. Address of pi. What is address of pi? Simply p is added to I, and because it is address, this is p plus I. So you could have either written and pi or simply p plus I. And how do you print the array? You use a for loop which again goes from 0 to n minus 1, and look, every time you are printing asterisk p plus I. Now instead of this, you could have written simply pi. Notice pi is nothing but p plus I, but we are not asking for address now, we are asking for value. So this whole thing is operated with asterisk operator, which will give us the value. The interesting thing is the last statement, you see, free p. What's the meaning of that? Free p. It means free the memory to which p is pointing. Correct? So if p was pointing to a list of 5 integers, that is 10 bytes, you know, 10 bytes. Now this memory is going to be returned. This memory is going to be returned back to the operating system. And it is as if p says, now I don't care about this memory anymore. It's very good practice. Just imagine you want an array of 10,000 elements. 10,000 elements. Then one way of declaring such an array is write int a 10,000. Correct? This will create an array of size 10,000. But the point is, this array will stay in the memory as long as your program runs. But who knows, after a certain point of time, this array is no more needed. You should be able to delete the array whenever it is not needed by your program anymore. Better approach would have been, instead of declaring an array like that with a name, better approach would have been that why don't you declare a pointer? You declare a simple pointer and then ask this pointer to point to newly allocated space, which is equal to size of one int multiplied by 10,000. Correct? What will then happen is P will store the base address of the allocated space. Just imagine this is that 10,000 element array. And later on, whenever this array is no more needed, you can just call free P. Oh, that's great. That means if you are not using some part of the memory, it is better to throw away or tell the operating system I am no more using that space, so that the operating system can use that space for some other purpose. So that's how you create array dynamically using Malloc. I hope you got enough. You understood all the aspects of this. Thank you very much.